So last day we have gathered a very basic idea about designing of a compiler. We have seen that what are the phases of uh, execution of a program, and we have concentrated on the compiler part only, and we have seen that there are several steps, and that basically converts a particular instruction or maybe a particular high level instruction to some machine level form, right? So now see, after that we have seen that what exactly lexical analysis mean. uh, we're not going in detail of lexical analysis, so we will do that later, but we stopped over here with these two questions. We have seen that if a grammar is ambiguous, then it is not accepted by a compiler. Why it is not accepted by a compiler? We have seen that there are two different parse tree, and because of that there is a possibility of generating wrong result. So somehow that's why before we give input a grammar to a compiler, the grammar should be unambiguous. Now how to convert this? At that at the time of realizing ambiguous grammar, there are two points encountered. One is precedence and one is associativity. What is precedence? Precedence say that if we have two different operators in a single in the same line, then which operator will be executed first? And if and what associativity say? Associativity suggests that if there is two operator of the same precedence in a same line, then which operator will act first? So the place of use of this precedence and associativity is little bit different. So let's take a first simple example. We will start with the similar type of example we have shown here. For example, like this. E to E plus E or E star E or maybe some ID. This particular grammar will generate all possible forms of mathematical formulation involving plus and star, right? Now you see, there is a very interesting thing, that suppose that there is an instruction, for example ID plus ID plus ID. You see, if the instruction is something like this, we will see that two different parts tree over here is possible to generate this particular string. For example, I will start from here, E to E plus E, and then again in this side E plus E. This can be ID, this can be ID, and this can be ID. This is one possibility, and another possibility is that E to E plus E, and now this side E to E plus E, and this will remain ID, and this will be ID, and this will be ID. Now see, both these strings generate the basically same string id plus id plus id. Then what is the difference? Difference is that if you look into the which particular addition will act first, you will see that in this left side part, this plus is in higher level over this plus, right? If we consider this is a parse tree, right? So obviously it's a tree, and in this tree, each and every node has some level. That's for clear. And level of this plus and level of this plus is obviously different, and this level of this plus is higher than this. Now when we will start executing, I mean start parsing the this particular string, I mean this particular tree with respect to the tree, then we will start from the node and we'll go downwards and right side, I mean top to bottom, left to right. This is the principle we know. According to that, this plus will encounter first, so naturally this plus will act first because of this e to e plus e, and after completion of this, that result will be added with this side. So that means according to the left side, this plus is left associative. If we have two pluses, basically it will generate a string something like, the computation of the string will be something like id plus id left one, and the result of this will be added with this one, something like this, right? The same string, but the computation will be in this way. But in this side, you see, it is totally different. I mean, I have plus. Don't mix with this particular symbol. This is plus. Okay. So here the situation is totally different, because in the right hand side you see that I started from E again. I cannot do this plus because this E has not been evaluated in the right hand side, and this can be evaluated only after this plus. So that means obviously right side plus will be executed first, right? So basically it will generate a string something like id plus id. This right side two part will be executed first because of this one, and then the first one will be added with the result, something like this. Now naturally, because they are same, their precedency is same, or maybe they are a plus, you will say that their result remains same. But remember, computer is a deterministic machine. The computer cannot decide by itself that what to do in which situation. Each and every rule has to be defined clearly to the computer without any ambiguity. Like if we have two operators with same precedence, then which operator will act first, that also we have to decide. We have to tell to the computer. Although the result is same, but still I have to say to the computer, because only the reason is computer is a deterministic machine. So this is one side. In another side, if we involve plus and star both in the formulation, for example, if the formulation is something like id plus id star id, there also you will see that obviously we have two different approach. We can start with e to e plus e, and then this side e star e, and this e to id, this e to another id, this e to another id. This is one side. In another side, we have e. We can have another problem, another way of drawing the parse tree of E to E, ID plus ID star ID, that is I will start with star, and in this side I will explode the left side, and this can be some same IDs, this can be some ID, and this can be some ID. Now one thing we have seen already from the previous case, that whatever in the higher level will act first, and since there was same operator in the different levels, that's why this whichever direction you are choosing for your for in the parse tree depends on that the associativity will come, because according to the left side of this we can say that plus is left associative, but according to right side it is said that plus is right associative. Now if you consider that plus is left associative in your grammar or in your language, then this particular right side parse tree is wrong. Similarly, if you come into the right side part, I mean in case of ID plus ID star ID this side, we will see that we have plus and star, so definitely we are assuming that they have different precedence. In case of different precedence, we see that in this left side of this of the ID plus ID star ID explanation of this tree, you see star is in the higher level of class, so naturally this star will be executed first, and then because of this E to E plus E star E, and then result will gets added with this one. That mean the you can say the part that will be the operator that will act first is obviously plus star. So that means basically ID plus ID star ID will look exactly something like ID star ID, and that will be added with ID, another third ID identifier, something like this. But if you look into this side, you see this here plus is in the higher level of star. So naturally this plus will act first, and that result will be multiplied with this. So basically you will get an explanation of ID plus ID star ID something like this. First two ID will be added first over here, and then it will be multiplied with some third ID identifier, which is basically wrong. This is basically wrong, and this is correct. Why correct? Because in your grammar you have considered star has higher precedence over plus. In suppose that in your grammar if you consider plus has higher precedence than star, then this part will become correct and this part will become wrong. So which is wrong or which is correct, that entirely depends on your what you are planning for your grammar. For example, if I say that star has higher precedence uh, over here in this grammar, in this particular grammar, if I say that star has higher precedence over plus, then this is this here. Another thing we can consider that plus is left associative. And based on this, we can say that this particular side is correct and this particular side is wrong. Now you see, since we have two different parse tree for the similar type of for the same string, that's why obviously we can understand this particular grammar is ambiguous. Now what problem is coming? Ambiguity is for what? Ambiguity is basically because of this confusion on the associativity and confusion on the precedence on this parse tree. That is the reason, right? That means if you want to convert your ambiguous grammar into some unambiguous form, then if we somehow able to handle this associativity and precedence properly, then my ambiguity will be will vanish. For example, what I mean to say is that if we have a grammar something like this, e to e plus e and e star e, that means what actually we are doing? What actually we are doing? We are actually, say for example, we are actually say trying to, we have some, say for example, uh, we started from e, and initially you have say taken this e to e plus e uh, in my parts tree. Now you see, for the next plus, for the next plus, I can go either, I can grow the tree either this side or I can grow either this side, both of the this. And now which part I have to, I mean in which side we have to grow, that depends upon what your associativity is, right? Because we have seen that if the plus is left associative, then we are growing the tree in the left side. If the plus is right associative, then we are growing the tree in the right hand side. That means we have to restrict the grammar to grow into one side based on which, based on the associativity. For example, suppose let's take the same grammar again. Let's take the same grammar. Okay, so basically we have a grammar like this, e plus e or e star e or id, and assume that we are thinking over here that plus is left associative, star is, suppose in your language star is right associative. Sorry. And star, the precedence of star is greater than plus, as simple as that. So considering these 3 points in our mind, you see, that means what is the point here, that since plus is left associative, that means what we have to do, that means I can say that okay, if we start from this e, if we start from e, and if we get, say for example, a plus, somehow we have to use this e plus e, fine, then we, since plus is left associative, if we have another plus, the another plus will grow in this direction, but not in right direction, right? But if we have a e over here, then we have a chance that it can be on the right side also. So that means somehow I cannot keep e in the right hand side. If I keep e, then I will have a possibility. that I can go in the right side also. And you that mean when we will write a corresponding corresponding you can say a modified grammar, I will have E over here, fine. Okay, I have over E. By the way, let's do one thing. Let's write in right hand side and let's draw this one in the here. Okay. What I told you that I start from E, that is fine. I have a E plus C, that's still okay. If I do in this way, and if since my plus is left positive, that plus should grow in this direction. I mean, I must write here that plus should grow in this direction, not in this direction, because plus is left positive, and that mean I have to restrict this by changing this variable over in the right hand side. So that mean when I will rewrite the production for this E to E plus E, what I can do, I will write E to E plus, I cannot write E, that means I have to introduce a new symbol T. E to E plus T. And if you do in this way, what will happen? That means the grammar will change here as if like E to E plus T, and somehow since E is given in the left hand side, so there is only one way you can grow in this direction. You cannot grow in the right hand side because it is not E. You cannot use this production rule again in the right hand side. Now question is that what about this plus? What about the star? You see, if I write, you can say that okay, then for the second production rule, I can say that okay, the opposite one, I can write that T star E. Now you see, if you do this, and if you have more than one star in the same equation, then what will happen? Then obviously you will start from, you will start with E. I mean, let's draw a situation that you will start with, say for example, E to what? T star E. T star E. And in this side, if another star occur, then definitely you will have a chance only grow in the right hand side, because in the left hand side it is not E. That means if we want to have another star, it will be in the right hand side, and naturally we can see that right side will be in the higher level, so right side star will be at first, so that means right will be right, the star will remain right as it is. That is correct, but this will create a new problem. You know what? This particular production rule, if we write in this way, it basically solves the problem of ambiguity based because of associativity. It can solve, but it is not solving the problem of precedence. The reason is that since E plus T and T star E both have same LHS, that is E, both can be rewritten from the same non-terminal E. That means if we have a plus and star combination, I can say that I can have a situation like this. I mean, same thing, just take it that ID plus ID star ID. Okay, just take this one. So if we start from here, I can say, okay, I can have use two different way. E to E plus T, and then in this side I will write E to T plus T star E. Right? And you see over here I can again generate, say for example, E plus T. That's very natural that I have to grow in the right hand side. Now if you look into this part, we see that this plus is higher level than this star. So naturally this plus will act first. Right? That means the formula that basically it can generate to ID, it can be ID, it can be ID, it can be ID. Say for example, just for time being, say I'm T to ID. That means what it is generating? It is generating a situation like ID star ID plus ID plus ID. And this one is act first, then this one, because next in this next this plus, that means then the addition. This is totally wrong, because if we have a star, it has the highest precedence. That means this straightforward changing from left or right, I mean introduction of a new variable in the left or right is solve the problem of associativity based, the problem of ambiguity based on, because of associativity, but it is not solving the problem of precedence. So to do this, what we have to do, one thing you can see from in the example, that somehow we have to change the left hand side equation, non-terminal. That means, if since we know that plus star must have the higher precedence of plus, and from the previous knowledge we have seen that the operator which has higher precedence must be in the higher level. So that means I can start E with this one, fine, but to remove this problem of precedence from here, what we can do, we can say that okay, I will have E to E plus T, that's fine. I will start from plus, and after plus I must have start. So from T this side I must have a start in the, mm, I mean the uh, in the higher level of that tree. So that means what I can write? I can write T to T star. You see what we are doing? We have started from plus and seen this star cannot came until plus came, because T to T star E and start symbol. This is my start symbol. So that means my parse tree will start from E, and I can, you know, I can basically explode it as E to E plus T, and then only we can explode this T side. And because of this T, if we explode T, that star will come and star will be in the higher level. So naturally, star will be acted first. But and one more thing, since I have kept T in the left hand side, it is now getting another problem. What problem? You see, just concentrate on the T part, okay? Just concentrate on the T to T star E part. If we do this, what will happen? The tree will be look something like this, right? T to T star E, again T star E, again T star E. So if we go on extending or exploring the this particular using this particular production rule, we will see that leftmost star has the higher level in the tree. So that means star is left associative. But that I don't want. I want star should be right associative. That means I cannot write T as T star E. Rather, we have to write T to, I'm sorry, we can say, you can say that, okay, E star T. But you know, if you write this T to E, T E star T, then also the problem is not still solved. Why? Let's show you. Let's take another situation. So let's erase this. Okay, let's erase this. You see, assume a situation like we started from E, obviously, because E is the start symbol. E to E plus T, and then we have grown this side, E to E star T, and then again E to E star T. That's okay. Yes, I know. That means from this tree I can say that star will be acted, this star will be acted first because it is in the higher level. So star is right associative. The problem is that since we have given a possibility to grow the tree from E again, that means here I can write somehow because of some string, it can be something like this also. Now problem is that since the plus is in the higher level, with respect to this situation, this plus, and if you compare this star, this plus will act first because it is in the higher level. So naturally the rule of precedence is violated because of this situation, right? That means as you have came into the star, you cannot keep any way to grow the plus in the left hand side. You cannot do this, right? That means we have to introduce again a new symbol over here. That is what we call, we can say for example if and this if can be, for example, some ID, but here it doesn't end. The problem, because reason is that according to this grammar, this product, the parse tree has to be started from E to E plus T. But in your equation, you may have a situation like only ID into ID into ID. This is also a valid mathematical equation, should be generated from this grammar, but it is not possible to generate from this grammar. Why? Because according to this grammar I must have a plus, because when I will use this production rule E to E plus T without having a plus operator, it will never work. That means we must give a provision to bypass this particular production rule, right? That is why, and where it will come after bypassing, it should come in the plus, in the star. So that means I have to write e to e plus t or t, so that it can bypass to this particular star by just you know you don't need to use this plus anymore in this particular string. Not only this, but also here also you see I have written t to f star t. So what's happening? It's happening something like t to f star t, f star t. This t is basically used to grow the tree in the right hand side, because I have seen that star is right associative, nothing more than that. But somewhere it has to stop. How I can stop? Ultimately it should lead to some id, but this id I have already written as f in the third production rule. That means I can write this t can be written as also f. Now see, we have given a chance this particular production rule to stop, and came some identifier. Now you see, from this production rule I can say that E is left associative. How I will put E as left associative? Just keep the leftmost symbol of the RHS is equal to the LHS of the production rule. Leftmost symbol of the RHS equal to LHS of the production rule for left associative. For the right associative, it is rightmost symbol of the LHS, rightmost symbol of the RHS equal to the LHS of the production rule. As simple as that. And since plus star has higher precedence, that's why you see I have kept star in the next production rule, but I have not used star as directly from the start symbol. Now if we apply this, so that means this grammar, so ultimately what we have seen, we are actually generating the same string with this grammar and this grammar. So that means language remains same, right? What is the difference? Difference is that this is ambiguous grammar, but this is unambiguous grammar. So this is a way that means if we somehow take care about this associativity and precedence in this way, we can convert any ambiguous grammar into unambiguous form.